Have you ever wondered how Netflix recommends movies that are just right for you, or how Spotify curates your daily mix? The answer might lie in a simple yet powerful algorithm known as K-nearest neighbors, or KNN. KNN, a cornerstone of machine learning, operates on a principle you may find familiar. Imagine you're at a party, you don't know anyone, but you want to mingle. How do you decide who to approach? You might look around and identify people who seem similar to you, right? In a nutshell, that's what KNN does, but with data points instead of people. Output. KNN is a type of instance-based learning algorithm. It doesn't make any assumptions about the underlying data distribution. Instead, it stores all the instances and uses them to predict the class of new instances. It's like having a photographic memory of all past data points and using that knowledge to make informed decisions about new data points. The K in KNN refers to the number of nearest neighbors the algorithm considers when making predictions. It's like choosing how many similar people at the party you want to consider before deciding whom to approach. The key is to choose a K value that reduces the overall error rate. The algorithm follows 3 simple steps. First, it calculates the distance between the new data point and all other points in the dataset. You can think of this as assessing how similar or different each person at the party is from you. Second, it identifies the K data points that are nearest to the new data point. This is like zeroing in on the K people who are most similar to you at the party. Finally, for classification tasks, it assigns the new data point to the class that most of its K nearest neighbors belong to. For regression tasks, it assigns the average value of the K nearest neighbors. This is akin to deciding to approach the group that most of your K similar people belong to. In the realm of machine learning, KNN is admired for its simplicity, versatility, and robustness. It's a non-parametric algorithm, meaning it makes no assumptions about the underlying data. It's fantastic for classification and regression tasks and handles multi-class cases well. Moreover, with an appropriate distance measure, it can work with any number of dimensions, making it a versatile tool in a data scientist's arsenal. However, remember that every rose has its thorn. KNN can be computationally expensive, especially with large data sets, as it needs to compute the distance to every other data point. It's also sensitive to irrelevant features and the scale of the data. To wrap up, KNN is a simple yet effective machine learning algorithm that classifies new data points based on their similarity to existing ones. It's like a social butterfly at a party, making informed decisions based on similarities. However, as with any algorithm, it's essential to understand its strengths and weaknesses to apply it effectively. So, next time you get a spot-on movie recommendation or a perfect song suggestion, remember the humble KNN algorithm might be working its magic behind the scenes.